The sun is secretly eating Mercury. NASA scientists capture terrifying footage. It drags a 3.5 million kilometer tail, speeding through space like a comet. But it's a planet. This phenomenon shouldn't even be happening. Even more bizarre, beneath the 460 degrees Celsius surface, there are billions of tons of ice, completely defying common sense. It's the closest planet to the sun, yet it has ice. It's not much bigger than the moon, but it has a magnetic field. Every discovery leaves scientists puzzled. In 2015, just 3 seconds before the Messenger probe crashed into Mercury, it sent back a final photo. The image captured the truest form of Mercury. Its surface is covered with massive cracks and craters, leaving the planet scarred. Scientists began rethinking the violent history Mercury had gone through. Today, our task is to restore the last truth Messenger saw and find out what happened to Mercury. What happened to Mercury? In 2001, German astronomer Schmidt, while observing from La Palma Island in Spain, captured a stunning scene using a high-precision telescope. Mercury had a faint tail stretching 3.5 million kilometers into the vastness of space, equivalent to 9 times the Earth-Moon distance. This completely overturned human understanding, because, in the solar system, only comets have beautiful tails. Mercury is a planet, not a comet. Why does it drag a tail hundreds of thousands of kilometers long, racing around the sun? Scientists, through spectral analysis, discovered this tail is entirely made of sodium atoms. The solar wind bombards Mercury's surface like countless tiny projectiles. Each impact lifts sodium atoms off the surface, sending them into space, creating the astonishing tail. Mercury, only 58 million kilometers from the sun, faces solar winds traveling at 1.5 million kilometers per second. This bombardment, which has lasted for 4.6 billion years, has ravaged Mercury beyond recognition. Even more terrifying, the surface of Mercury is covered with countless craters. The largest of these, the Caloris Basin, has a diameter of 1,550 kilometers, created by an asteroid more than 100 kilometers wide that struck the planet 3.8 billion years ago. The impact was equivalent to the explosion of 1 trillion tons of TNT, shaking Mercury into a distorted shape. On the opposite side of the impact, a 2-kilometer-high mountain range rose. This is a famous bizarre terrain. Scientists speculate that this impact nearly altered Mercury's entire structure. The massive fault systems on its surface are likely remnants of this ancient collision. But what's truly bizarre about Mercury isn't just these physical features, but its scorching iron core. Mercury, with a diameter of only 4,879 kilometers, is barely larger than the Moon. According to planetary evolution theory, such a small planet's core should have long since cooled and solidified, yet Mercury refuses to follow the usual path. Its iron core makes up over 60% of the planet's volume, and part of it remains molten to this day. This is unique among the 8 planets in the solar system. Mars, much larger than Mercury, has long lost its magnetic field. Why does Mercury remain so resilient? In 2002, scientists, through high-precision measurements, discovered an astonishing phenomenon. Mercury wobbles slightly as it rotates. This wobble could only be explained by one possibility. There's a liquid core inside. This discovery immediately set the academic world ablaze, because it meant that Mercury's inner structure was completely different from what was imagined. It wasn't a pure iron core, but rather a sulfur-rich iron sulfide core, which has a lower melting point. This allows Mercury's interior to remain partially molten even today. However, a problem arises. Sulfur, a volatile element, should have been blown away by solar wind, given Mercury's proximity to the sun. Unless Mercury didn't originally form in its current position, it might have come from a farther distance and was later pushed to its current orbit by some violent event. Scientists have proposed 3 bold theories about Mercury's origins. The first suggests that Mercury originally formed between Earth and Mars, but was struck by an asteroid several hundred kilometers wide. an impact that not only stripped most of its crust, but also changed its orbit. The second, more violent theory posits that Mercury formed right next to the Sun. However, early solar energy output was unstable, causing surface temperatures to rise to thousands of degrees Celsius. Rocks vaporized and were blown away by solar winds, leaving only the iron core. The third theory suggests that Mercury's outer layers were stripped away by the Sun during planetary formation, because in the early stages, Mercury was at a disadvantage compared to the Sun in the competition for surrounding material. To test these theories, NASA launched a Messenger probe in 2004. After a 7-year journey, it finally entered Mercury's orbit in 2011 and began the most detailed survey of Mercury in human history. Over the course of 4 years, Messenger orbited Mercury 4,104 times, taking more than 270,000 photos and mapping the planet for the first time. In 2012, Messenger sent back explosive news. Large amounts of water ice were discovered in the craters at Mercury's north and south poles. The total amount could reach several hundred billion tons. These ice deposits are located in permanent shadow regions where the temperature remains below minus 170 degrees Celsius, and they have never been exposed to sunlight. Scientists speculate that these ice deposits might have been brought to Mercury by comets that collided with the planet billions of years ago. Even more astonishing, Messenger also detected traces of organic molecules in Mercury's thin atmosphere, suggesting that the planet might possess the conditions for complex chemical reactions. However, this does not mean that Mercury harbors life, as the daytime temperature of 430 degrees Celsius would be enough to destroy any known life forms. On April 30th, 2015, Messenger ran out of fuel and, as planned, crashed into Mercury's surface at a speed of 14,400 kilometers per hour. In the final seconds before the impact, Messenger managed to send back one last photo, a barren, crater-filled landscape just a few hundred meters above the surface. The image was rough but awe-inspiring, a poignant farewell to Mercury. Messenger's sacrifice was not the end. In October 2018, the European Space Agency and Japan jointly launched the breathtaking probe, a more ambitious mission consisting of 2 orbiters, one to study Mercury's surface and the other to investigate its magnetic field. In October 2021, breathtaking made its first flyby of Mercury, sending back higher-resolution photos. By the end of 2025, it will officially enter Mercury's orbit and begin a year-long scientific study. Now, scientists' main concern is, how much longer will Mercury survive? Every year, solar wind strips away about 10 tons of material from Mercury's surface. While this doesn't sound like much, over 4.6 billion years, Mercury has lost a significant amount of mass. At this rate, Mercury's fate will be closely tied to the Sun. However, before that, Mercury might face an even greater crisis. Mercury's orbital eccentricity is 0.21, the highest among the 8 planets, meaning its orbit is relatively unstable. French astronomer Lasker, through computer simulations, found that there is a possibility that Mercury's orbit could undergo drastic changes in the coming billions of years. Although the probability is small, it is not entirely impossible. A 2024 study shows that Mercury's magnetic field strength is only about 1% of Earth's, and the magnetic field center is offset from the planet's center by about 480 kilometers. This asymmetrical magnetic field makes Mercury more susceptible to solar wind erosion. Scientists predict that as Mercury's core continues to cool, its magnetic field may continue to weaken, accelerating the process of solar wind stripping material from Mercury's surface. Mercury's existence itself is a mystery in the evolution of the solar system. It is too small, too close, and its environment too extreme, yet it has stubbornly persisted for 4.6 billion years. It follows a unique orbit, maintains its magnetic field with its scorching iron heart, and bears the scars of the solar system's ancient and violent history. When breathtaking reaches this mysterious planet in 2025, will it reveal any cognitive disrupting discoveries? We'll wait and see.